We've already talked about some aspects of this northward propagation, but in the context of this model, it's a bit more specific. So the idea in this model is that the stretching structures of going from northwest tropical Pacific over to India and northwestward are essentially Rossby waves generated over here, and of course we know that pure Rossby waves would propagate westward. So what would explain their northward propagation? Remembering that not every theory for MISOs argues that the northward propagating systems are coming from the West Pacific. Okay, so this is what we saw before, going from t equals minus 20, minus 15, minus 10, and so on. So you are starting with one phase. Here we are looking at evolution of convection and relative vorticity over a 30 to 60 day mode. They are basically regressed filtered anomalies of OLR and relative vorticity. It doesn't matter. Basically you are starting with one phase at minus 4 pentads, and over time in 3 pentads you are coming back to the same phase after changing phase. So this indicates the northward propagation. So you can see this negative sign here going northward, occupying the place that was occupied by the positive phase, and then the next positive phase gets set up over the deep tropical Pacific and crosses over. And this part is not necessarily addressed here. We are only looking at the Rossby waves and then the northward part here, because the other way to think about it, as I showed, is that there is the marine ITCZ here, there is a lot of action here, and as sun moves north, ITCZ moves north on the eastern side, on the western side, but here it is split into the monsoon tropical convergence zone and the marine intertropical convergence zone. The story in this paper is to use a barotropic component of the vorticity equation, which is written this way. You can find this in the Wong and Xi paper, I think. So d zeta dt is minus beta v plus, where these are the barotropic components, minus the vertical shear times d omega dy, where omega again is the vertical velocity in the pressure coordinate and its meridional gradient, which is what we are looking at here. So you can see that the vertical velocity is subsiding here, and you have strong convection originating, let's say, in the tropical region, which has strong vertical velocity and has vertical motion around it, and you have the background easterly shear associated with the background monsoon circulation, the low latitude westerly jet and the upper easterly jet. So you curl your fingers around it, you get a horizontal barotropic vorticity that is written here as zeta bar u, and the vertical motion is going to tilt the vorticity or twist it and create a vertical component to it. And you can see that on this side it's being tilted upward, on this side it's being tilted downward, and there are, once you tilt the vorticity up or down, you're going to create a corresponding circulation at the surface. So there is a baroclinic mode set up, so the barotropic and baroclinic modes are going to get coupled. So you're going to create a anticyclonic circulation on this side and a cyclonic circulation on this side, and twisted vorticity that's positive on this side and negative on this side, and the d omega dy term is basically going to feed on that. And the background circulation is also going to give us a moisture gradient going from the tropics towards the Indian subcontinent, or most of the times it's over the Bay of Bengal. So Bay of Bengal northern section is much more humid than the tropical part of it, and that's going to help the circulation, cyclonic circulation and convergence to grow in front, northward of the existing convection. So it is the this background easterly shear that's argued to be most critical for northward propagation or displacement of the Rossby waves that are coming westward from the Pacific. Okay, and the air-sea interactions are also invoked as being favorable in addition to the humidity gradient, and this is from a nice paper by Gabe Vecchi and Ed Harrison, which looked at the relation between sea surface temperatures, shown here as red for warm and bluish, greenish, whatever color for cold, and there is a lagged relation between them. The warm SSTs get set up with the corresponding wind anomalies shown here. Then convection gets organized, let's say, in about a week to 10 days, and you can see that the winds get stronger because they are adding to the background winds, and the SSTs cool. So eventually the convection dies, and the background circulation here are the southwesterlies associated with the cold SSTs of the so-called Sri Lanka dome and so on, which we are not going to worry about now. But the convection again gets organized to the tropical side of it, like we have seen here, and that's going to again going to follow the SST. So SST is going to have weaker winds, more radiation, and is going to reorganize into a warm SST like this. So the idea is that in addition to the easterly shear and the vorticity twisting and the frictional convergence associated with that tilting, you also have this SST that's favoring northward propagation of the Rossby waves. Okay, that's the main idea of this particular model that we have been looking at, but there are other ideas proposed. This one from Zolay, which the group has produced several papers. I am on some of them, and their argument is that if you look at the coupled EOF of the intraseasonal sea surface temperatures and zonal winds, this is the kind of structure you get. So you have warm SST anomalies at interseasonal timescales in the deep tropics associated with easterly winds, and you have colder SSTs and westerly winds over here. So you have a horizontal shear instead of the vertical shear that is argued to be critical for providing the energy, barotropic instability providing the eddy kinetic energy for northward propagation. Of course, it's not completely settled yet, but this idea also invokes a connection to the deep convection on the western Pacific side. It says this deep convection here has a intraseasonal Walker cell connection to the deep tropical Indian Ocean, creating a downdraft and giving, of course, the vertical shear, but also this easterly winds and the barotropic instability and the needed energy for northward propagation. So a phase relation between active break active in this direction is proposed, and we also know that there is also a active break kind of connection between the tropics and the Indian subcontinent, because as we saw in the 30 to 60 day mode, when there is convection over the Indian subcontinent, there is subsidence over here. So now you have a story that is connected in the east-west as well as in the north-south. So obviously this is not yet complete, but it points to many open questions as far as northward propagation is concerned. And of course the scales as well, because in the Bin Wang paper they don't separate the quasi-biweekly mode. We talked about the shifted Rossby waves generated locally with the boundary layer processes and the heating associated with that, with a smaller zonal scale, versus the 30 to 60 day mode, which has this larger tilting structure from the southeast to the northwest. So the two modes are apparently independent, different scales, different processes, but what are the processes that are actually functional are still kind of debated. Okay, so that adds a little bit more flavor to the processes that we are looking at intraseasonal timescales, and the idea of whether really the interseasonal oscillations are in the boreal summer are coming from the west, or they're originating let's say over the western Indian Ocean, trying to propagate eastward but getting detoured northward, and so on, are all still open questions. So we will leave it there for now and move on to a little bit more details about the air-sea interactions in the northward propagations. Okay.